The Acute Chronic Workload Ratio, also known as the ACWR, is comprised of an athlete's fitness and fatigue and can be calculated using either the rolling average model or the exponentially weighted moving average model. The ACWR is a very simple ratio that is calculated by dividing the acute workload from the last week by the chronic workload from the last 4 weeks. It was shown in previous research that a ratio of more than 1.5 is correlated with increased injury risk by 2 to 4 times in the subsequent 7 days. On the other hand, a ratio of less than 0.8 was correlated with decreased fitness levels. Thus, it was decided by Gabbett et al. That values of 0.8 to 1.3 are the optimal workload, or in other words, the sweet spot. The big advantage in using the acute to chronic workload ratio is that we could use any kind of metric that quantify workload. For example, we could use external load metrics such as total distance covered, player load, or weight lifted. Or we could use an internal load metric such as heart rate or RPE. This is what makes the ACWR so popular and common. The fact that coaches can use any kind of data to apply this ratio in practice. However, there are some limitations to the ACWR that a lot of practitioners are not aware of. In the next few slides, I'm going to go over some of these limitations that you, as sports scientists and practitioners, must be aware of. That is not to say the ACWR is useless, but to know its drawbacks. The first limitation, or group of limitations, of the ACWR is the methodology part of the ratio. Initially, the ACWR was based on training load data from 2 studies, one from cricket and the other from rugby. Then, the training load data was combined with unpublished data from the sport of hockey, meaning that the authors combined likelihoods of injury values calculated from the exposure to different measures of training load, such as distance, RPE, and counts. In addition, the ACWR values were combined into discrete categories, and the likelihoods of injury and risk of injury were calculated relative to each category. On top of this discretization, the authors attributed some likelihoods of injury values to different categories than they were originally calculated. For example, an ACWR value of less than 0.3 and an ACWR value of 11.8, both of which are not shown on the graph. A different limitation of the ACWR is its use in averages, as averages overlook variations within the set periods of time. As you can see on the graph, the ACWR values are the same for these 3 athletes, meaning they all have the same injury risk. But if you dive into the details and look at the variations of their training load, you would be able to see that they are very different. So, in other words, use of averages neglects the aspects that the effect of a training stimulus declines over time, meaning that chronic load considers training session 1 day before the analysis equal to a session 4 weeks before. Another limitation of the ACWR is that it has a confounding effect. What this means is that a training schedule confounds the ACWR injury relationship. Bourne et al. Simulated 1,000 player seasons both in soccer and American football using the observed team schedules and training loads, where the probability of injury in a given session is directly proportional to the load in that session, meaning ACWR has no influence. Even though they simulated seasons in a way that ACWR has no impact on injury risk, they found a meaningful relationship between ACWR and injury. Lastly, another limitation of the ACWR is a mathematical limitation. The ACWR has another source of error due to what is called mathematical coupling. Mathematical coupling occurs when one variable directly or indirectly contains the whole or part of another. The problem with this is that it causes false correlation. Now, the acute load, the numerator, constitutes a substantial part of the chronic load, the denominator. We now have a perfect example for mathematical coupling. To prove this, a simulation by Lolli et al. Of 4 7-day periods of high-speed distance data for 1,000 players found a moderate to large positive correlation between the calculated chronic and acute load data, with an R value of 0.52, when the A, the acute load, was not included in the calculation of C, the chronic load. The calculation between A and C was, as expected, close to 0, with an R value of 0.01. This is indeed a perfect example for mathematical coupling.